So let's have a look at number 4 here. It says in a particular circuit, the current I amps is given by some formula. And we're told that I equals 4 sine theta minus 3 cos theta, where theta is greater than 0 and theta is an angle related to the voltage. We're told here, given that I equals r sine theta minus alpha, and we are given some conditions on r, we've been asked to work out r and alpha. Well, if I equals r sine theta minus alpha, my starting point is to say 4 sine theta minus 3 cos theta is equal to r sine theta minus alpha. And from there, I am going to use the addition rule for sine and expand r into that. So sine theta cos alpha minus cos theta sine alpha. And if I expand r into that, I get r sine theta cos alpha minus r cos theta sine alpha. And that obviously is equal to 4 sine theta minus 3 cos theta. Now what we're trying to do here is to work out r and alpha. In order for us to do that, we need to equate coefficients. Now what does that mean? That means we look at this sine theta on the right hand side. What is the coefficient of r sine theta on the right hand side? Well, r sine theta has been multiplied by r cos alpha. So we can then create an equation on the right hand side that r cos alpha, and then if we look at sine theta on the left hand side, sine theta has been multiplied by 4. So the coefficient of sine theta on the left hand side is 4. And when we equate coefficients, we get r cos alpha equals 4. Similarly, if we look at cos theta and cos theta, we've got, on the right hand side, we've got minus r sine alpha is being multiplied by cos theta, and on the left hand side we've got minus 3. The minuses cancel and we get r sine alpha equals 3. Now from there, see, your teacher might have taught you slightly differently, but I like using SOHCAHTOA from this point forward. So I make cos A the subject, and I say that is 4 over r, and sine A is 3 over r. And using SOHCAHTOA and a right angled triangle, if I call this angle alpha, adjacent over hypotenuse must be 4 over r. So the adjacent must have been 4 and the hypotenuse must have been r. Sine is opposite over hypotenuse, so the opposite must have been 3. And we've already got r as being the hypotenuse there. And from this we get r equals, well, if we use Pythagoras, we get r equals square root of 3 squared plus 4 squared, which is 5. And from this triangle, we get that tan alpha equals 3 over 4, because we've got opposite and adjacent. So A is going to equal inverse tan of 3 over 4. And we get 36.9. And so what we have found out in part A is that 4 sine theta minus 3 cos theta is the same as 5 sine theta minus 36.9. Now again, like I'm saying, your teachers might have taught you slightly differently how to get R and alpha. Ultimately, the answers should still be the same. Right, let's move on to part B. Now part B is saying, hence solve the equation 4 sine theta minus 3 cos theta equals 3. 4 sine theta, minus 3 cos theta equals 3. Keyword in there is hence. Hence implies we should use something we have worked out earlier. And we are going to use the r sine theta minus alpha form. So we can replace the left-hand side here with 5 sine theta minus 36.9 equals 3. So now we've got a trig equation, first year stuff. Sine theta minus 36.9 equals 3 over 5. So now, if I just deal with this as being in a cast diagram from 0 to 360, think about CAST, I've got sine as being positive. If I get a negative value for theta, I will work out either the previous solution or the one after. Actually, it won't be the one after, it'll be the previous solution to help me bring it back in range. But I will only do that if I need to. So looking at this, between 0 and 360, where is sine positive? Sine is positive in A and in S. And if I work out theta minus 36.9 equals the sine inverse of 3 over 5, which as it happens is exactly 36.9, because it's the same triangle as this. R was 5, so inverse sine of 3 over 5 is going to give me the same alpha, 36.9. But we can verify this. Inverse sine of 3 over 5, and we get the same answer. I'm going to store that in A. Now, that tells us the angle from the horizontal is 36.9 here and 36.9 here. So the two solutions for theta minus 36.9 are 36.9, and the second one is going to be 180 minus 36.9, which is 143.1. And so if I work out theta now, I'm going to add 36.9 to each one. So I'll do alpha A plus alpha A, and we get 73.7 as my first solution. And the second solution has 180 minus alpha A would have been plus alpha A, essentially cancelling it out, and we get 180 degrees. Or if we add 36.9 to 143, we're going to get 180. Either way, that is the right answer. So that's part B done now. Let's have a look at part C. It says write down the greatest value for I. Now, I, which was given to us, is the same as 5 sine theta minus 36.9 degrees. Now, if we think about this, there have been two transformations on the sine graph. If you think about the sine graph, the maximum's 1, the minimum's -1, and between 0 and 360 will take up one cycle of the sine graph. So this is sine theta. If I now do the first transformation, which is 5 sine theta, 5 is outside essentially the brackets, so that means I need to multiply my y values by 5. So that will lead to a stretch in the y scale factor 5. And at the moment it's still 0 to 360 to fit in one cycle. But now we've got theta minus 36.9. That means the sine graph has shifted right by 36.9 degrees. And instead of starting at the origin, it starts at 36.9. Obviously, so this is 36.9. This would be 396.9. This is still 5. This is still -5. So here is 5 sine theta minus 36.9. So in part C, when it asks us to write down the greatest value of I, the greatest value is simply the y value, and the greatest value therefore is 5. Part D, find the value of theta between 0 and 360 at which this I value occurs. Well, if there wasn't a translation to the right by 36.9 degrees, it would have been at 90. However, this graph has shifted right by 36.9. So what we can say then is 90 plus 36.9, which is 126.9 degrees.